Hello everyone, and welcome to today's edition of Java for Everyone, JFE. I'd like to welcome all of you. I hope you guys are doing well. First of all, maybe I can make sure that you guys can see my screen and that you can hear me. So if you can see my screen, do a thumbs up or... hello everyone, welcome to today's edition of Java for Everyone. And before I begin, I hope you guys are doing well, and I'm excited for today's session. We'll be looking at more of Java collections framework, specifically ArrayList. ArrayList has a lot of capabilities, and like I mentioned or we covered last time, it is the most used collection, so we'll be spending some more time exploring it, and I will try not to rush that process because it's a very important component of the Java collections framework. So that's what we'll be continuing with this session. And yeah, I know you guys are looking forward to like the World Cup, so I'll try and start early so that I don't eat into that time if any of you guys are watching the game. Okay, so otherwise, I welcome you all, and like is tradition, maybe you can begin by getting any questions or feedback from the previous session that we had on Java collections. If you have a question on what we covered last time, feel free to unmute, and I'll be more than happy to clarify. Anyone? If you, okay. So I guess that means we are in the same page. So I'll just go ahead and start. But first, before I start, let me just make sure. Do a thumbs up if you can see my screen and you can hear me. Okay, that's good. Okay, so let's go ahead and start with today's session. Again, maybe I should also mention, as usual, if you have any question, feel free to just unmute and ask. Don't wait for me to pause or wait for the end. The end is not guaranteed. So if you have any questions, just ask, or if I get anything wrong, please feel free to interrupt. So what did we cover last time? So we've done 2 sessions on ArrayList so far, and we've been looking at ArrayList's core operations. And the core operations of ArrayList that we were able to look at, let me just make sure that this font is good. Get it 150 would be better. Yeah, so the core operations of ArrayList that we were able to cover last time, the past 2 sessions that are related to ArrayList are, so these are core ArrayList operations, and we're able to look at how to create an array list. So I think I remember that's the first thing we did, creating an array list, and we learned about capacity and the difference between capacity and size. Then we learned how to add elements with the add function. So we learned how to add elements to an array list, and we learned how to retrieve elements using the get method. And the other thing we looked at was how to update elements. So if you remember, we covered that set function. So the set function is the one we were using to update the array list. And yeah, we even learned how to remove elements from the array list, and how to perform, we'll cover our additional bulk operations, but the bulk operation that we were able to cover last time is to add all, ability to add all elements. I don't think we covered remove all, but we'll cover that also on like its own dedicated section. So this is so far I believe what we've been able to learn. So last time I was interrupted when we were looking at these two functions. I think that's how we ended the previous session. So this is what we covered. Just clear that. If you have any questions related to those operations, feel free to let me know. So today we'll be looking at index of and last index of. And index of and last index of form part of the core operations that we've been exploring. And after core operations, we'll be looking at bulk operations, which will also include one of the operations that I've listed there. What does index of and last index of allow us to do? So let's start with the index of. So in the previous session, we created this record called location. I told you can consider it as just a class with a shorthand so that you don't have to do getters and setters on your own. So that is one main advantage of it. So we're able to look at we're able to create this location record, and we're using that location record, we're able to create a list of locations using the latitude and longitude, and that list of locations we're able to add it to an array list like so, using the add function. And we believe we got to the point where we are sure that we had the values. So we have the values in the array list. So these are the locations, latitude and longitude. To best demonstrate this, I think I'd rather simplify this sample so that our output is a bit more clear. So I'll just use a simple double for the location. So we will still have locations, but I want it to be as simple as possible so that we can explore this a bit easier. So these locations will be just double. Assume we are locating based on latitude alone or longitude alone. So with doubles, you can create them by adding the floating point values. Also, you can just add that postfix of D, and that will make it a double, the same way we make float using the F. So with that will make it a double. So just in case you don't want to add decimal points. So I'll also add 11 there, and I'll add one where we are using the decimal points, 4.23 for example. And now let me just make sure that those values are there. So the output is a bit nicer, so as opposed to what we had earlier. That's why I've defaulted to using this. So let's see what last index of allows us to do. So we'll start by exploring index of first. And what index of does is it is a cousin to a function that we explored while covering the collection interface, and the function is contains. So what does contains do? So with contains, you can call contains on any collection, and it will tell you whether that element is contained in that collection. Just go back to the code we wrote here in the freezer collection, and we had this contains function, this one. And as you can see, it receives an element, and then it checks. First of all, of course, we are checking whether that element is the same type as what is stored in this collection using this instance of check. And within here, we would go ahead and check if the property of the element, which was the name here, is the same as any of the names contained, any of the values contained within this collection. And with the elements was the array list that was contained inside this collection. So basically what we are doing here is, if you imagine the collection as a box, we have this box. Let's imagine the box contains different colored balls. There are blue balls, red balls, green balls in there. And we have in our hand a yellow ball. And we want to check whether this yellow ball is contained inside the box. Maybe we want to make sure that we don't duplicate, we don't add the color of ball that's already contained in the box. So the way you achieve that is you call contains, and contains will check for you inside the box whether there's another ball with the same color, essentially. So that is a function that we looked at. I believe we explored it exhaustively. So we can apply, since array lists and lists are collections, they all inherit from collection, just like our freezer collection here. We can use that same contains function, and we can say locations.contains, and we can pass in a value that we want to check. So maybe we want to check whether it contains maybe perhaps 4.1. So we want to check, so this is the collection. Does it contain 4.1? And if it contains 4.1, I believe we are supposed to get a Boolean value. Boolean contains. Maybe you can name it better, call this is contained. So that is essentially what contains allows us to do. And if we were to print out the output of this, so is 4.1 contained in locations, and we can try and see what the value of is contained is. If we run this, we'll see that the output is 4.1 contained in locations is false, because there is no 4.1 here. But if we passed in a value that's contained, I'll try and do it in line this time. So let's check for a value that we know is present. So we have 11.0. So that 11.0, let's check if 11.0 is contained in locations. And the way we can do that is we can call locations and call contains, and we pass in 11.0. And if we run it, we'll see 11.0 contained in locations is true. So it allows us to check whether a value is contained. So last index of is somewhat related to this, in that instead of just checking whether this value is contained, it will give you the index of where this value actually is. So let's do an example. Let's call locations dot index of, and we want to check the index of 11.0. So what will that give us? So this will give us the index in form of an integer, of course, because integers are their size is just enough to store or rather reference the positions of elements. This is a callback to arrays, essentially. So this index of will give us an integer, and the integer is the index of the value. So index of value, in this case 11.0. You can say 11D there, since you guys I'm sure know what the D represents. And if we print this, we'll be able to get the index of. So index of 11.0 is that index of. I'm using okay, yeah. So let's see what that gives us. So index of 11.0 is 1, and if we check our, in fact, let me just comment this out so that we can check it a bit faster. So it's telling us that index of 11.0 is 1, and you can see in our array list the first index, which is index 0. Remember, array lists are 0 index, so the first index is 34.0. So the first index, which is index 0, is 34.0. The second index, which is index 1, is 11.0, and the third index, which is index 2, is 4.23. So correctly, it's giving us 11 being at index 1. Let's see a different value like 34. So inline this again, locations.index of 34.0. I believe you can still use 34D. Should still work. And we see that the index is 0. So 0, which is the actual index, and then 1. And now if we do 4.23, we should get index 2. So 4.23, and if we pass in the same value here, 4.23, we should be able to get the index. So index is 2. So 4.23 is at the end here. So you have 0, you have 1, you have 2. So that's how it ends up as 2. An interesting, curious thing is, what if we checked for a value that doesn't exist? So we already know 4.1 is not part of our array list. So what if we check the index of 4.1? Can somebody tell us what might happen here? What happens when we check for an index? We check for an index of a value that doesn't exist in the array list. Anyone? Even if it's just a guess. Anyone wants to give it a try? Or we just... Yes?
Index out of bounds.
Oh, you get an index out of bounds, right?
I think, yeah.
Okay. Let's see. So let's run it. Actually, we don't get an index out of bounds. We get a -1.
Oh, it's not a get, sorry.
Oh, it's index of. And this is thanks for that. I think that was Joe. Thanks for that, Joe. So this is something that I would encourage you guys to keep in the back of your minds when you're working with Java collections. Is there are situations where you get if you do the wrong thing or the unexpected thing, you get an exception. But there are cases where you get a flag. So things like -1, sometimes 0, are used as flags. So 0, 1, and -1. So if you're doing an operation that looks at those as valid values, you have to be very careful with how you write your collection. Because if, for instance, I was doing this index of operation, and maybe the index of was pointing towards the student's fee balance. So I do an index of, if I don't get a value, I return what I get from index of. If I get a value that's valid, I use that. Because somebody might be expecting an exception to happen here, they might return this -1 as a valid value as the student's fee balance. And it might lead to undefined behavior. So you have to be very careful about these APIs and learn how internally they'll behave. So in this case, the index of, as opposed to get, if we did get, we would get a proper index out of bounds error and would know that something went wrong. But when it comes to this index of function, you get a -1 if you pass in an invalid index. So let's just try and see whether that's a consistent behavior. Let's pass in 1.1, which we know doesn't exist. 1.1. So if you pass in 1.1 again, we get -1. So this -1 is not an indication of index, it's an indication of invalid index. It's like the API telling you, I'm sending you -1 because the index you're looking for doesn't exist. So another way of saying error, -1. I'm sure you've run some programs, and when they fail, at the bottom there it says exit with error code 1 or exit with error code 0. And that error code, though it's an integer value, it's an indication of an error happening. So just know that if it fails, you get a -1 here. Any questions on that? Okay, yes. Was somebody speaking? Go ahead. Okay. But feel free to interrupt or leave a message on the chat. Yeah.
Maybe for users, And I think they have to be cautious not to use the wrapper classes for performance-based computing because they are quite slow, to be honest. The boxing of primitives there, the double float. If you use the classes, they tend to have a performance issue. But if it's code for convenience, they are the best to use. Yeah, that's what I wanted to say.
Thanks for that, Joe. So that's something to consider. I think what Joe is referring to is double and double, or integer, if you're using integer, or int. So whenever you are writing any program, and I think if this is not what you are referring to, Joe, you can correct me. So whenever you are writing your programs within Java, use double when you have to, because there's an additional cost when it comes to using boxed types. And I think from recently what I've learned from some of our discussions is the way these work internally is they use pointer referencing. So the double will be an object that points to another memory location where an actual integer is stored. So there's some additional overhead when you're doing your operations, but if you use primitive times, they're mapped directly to memory. There's no additional referencing being done, and your code can potentially be more optimal. I think that's what you're referring to, Joe. Correct me if I'm wrong.
Yeah, well explained actually. Yeah.
Oh, awesome. Yes, so for performance reasons, use double, use integer, use float with uppercase F when you have to. But if your program is working well, always prefer to use primitives. And very soon in Java we'll have value classes, which is another discussion that we will have soon, and this will address most of these performance hitches that might exist in the language. Basically, it will just make the language lightning fast, or your programs lightning fast. Okay, so so that I don't digress too much. So this is index of, and we've seen the behavior. So let's look at last index of. So with the last index of, I think the best way to demonstrate last index of is, I'd like to preserve this in case any of you want to come back to it later. So if you guys, so I'll just go ahead and, I want to preserve that. So this covers index of. I'll create another file to cover last index of. And if anybody has some idea on naming conventions so that I can arrange these files better, feel free to suggest. Otherwise, I'll use this v2 sort of thing. So this is the third session. So on ArrayList, so this is v31.java, which I can call v3.java. So when you are revising and you are looking to reference some of the code we are doing, just know that I'm separating them into individual files, so that it's all the as much of the source code is preserved as possible, so that we don't delete things. So let's now look at index of. So we looked at index of. Let's look at last index of. So with this, we need to consider something that we covered earlier, which is that lists, and by extension array lists, one of their core characteristics is that they allow duplication. So you can duplicate elements. We also talked about them allowing nulls. So this is another thing that you need to consider. But the most important for this particular example is that they allow duplication. So what does that mean? That means we can create a list here of floats and say, let me just call it list. And it's an array list, of course. And in this list, we add a float value, maybe 4.2f, then another float value of 3.1f, and perhaps so imagine this is maybe you're measuring the speed of something that's moving through some distance. So there's some instances where the speed will be the same. It will accelerate and decelerate and come back to the same speed. So you might have values that are repeating. So you might end up with 3.1 again. And maybe the object whose speed you're measuring might return back to 4.2. That's an acceleration. Might accelerate again to 4.2. And then it might okay, let me leave it there. So here we started at a very high speed, decelerates to 3.1, maintains 3.1, and then increases to 4.2. So one thing you can see with these values is that they are duplicating. There are instances where they are the same, and ArrayLists allows this behavior, so that you can write programs like that that measure the performance of F1 drivers, for example. And here, if we print out our list, and make it culturally relevant. So this is speeds. So we are in some F1 track, and we are measuring the performance of the drivers, and this is how the speeds are going. So if we print the speeds here, I remember ArrayList comes with an inbuilt toString, so we don't need to do extra work. Yeah, and we get the speeds here. So it starts with 4.2, moves to 3.1, 3.1, 4.2. So you can see we can duplicate. We can have the same value repeated. Now, what if we want to know when was the last time they were at 3.1, for instance? So we know they were at 3.1. When was the last time they were at 3.1? So with that, you can use last index of. So last index of checks for the last time a value appears in the array list. And we can do that here, since I hope you guys are used to the inlining things, that I don't have to create additional variable. So last occurrence, too many is, last occurrence of 3.1, because we know 3.1, that speed duplicates. So last occurrence of 3.1 is, and we can come here and say speeds dot last index of 3.1. So just like because it's expecting floats, so just like the contains function, last index of accepts an object. It accepts one of the elements. Of course, it will go in, first thing it will check whether it's contained. I'm assuming it will check whether it's contained, because why you look for an index of something that is not even in the array list. And then now it will check for which indexes it appears in. In our case, we know it appears in, this is index 1, because this is 0. This is index 1, and the other index here is index 2, and this other index is index 3. So 3.1 appears in 1 and 2. So let's see what last index of will give us. So you'll see last occurrence of 3.1 is 2. So this is the last time we got 3.1. So when was the last time we got 4.2? 4.2. So we'll just do the same thing here, and we are looking for 4.2. And if we run it, we get last occurrence of 4.2 is 3, which is this index. So it doesn't give you 0, so it gives you 3. So that's the what you can achieve with last index of. Might seem like a small thing, but if you don't know that this API exists, what usually happens is you'll find developers crafting very complicated algorithms to do things that are already built into the language. So you'll find somebody here they'll write a for loop, and then they'll iterate over the values, they'll compare them and track the indexes, and when they find the index, they see whether index is greater than the last index. So all of that is already done for you inside the language, so you don't have to write complex algorithms to achieve that. So that's the importance of knowing some of these available API functions. So that's what you can achieve with last index of. Let's just like the other one. Let's see what happens if we pass in a speed that they didn't reach. Maybe they're looking for 11.3, and we know they did get to 11.3. Let's see what the API will do. So if I run that, we see it does the same behavior with index of, in that if we check for a value that doesn't exist, you get a -1. And even if we go to, okay, so this is the list interface. So if we go to ArrayList, which I have here, java.util.arraylist, and if we look for last index of, so we'll find this function. So this is the function we are calling. And of course, it's calling some other internal functions. So I think they're using that because it has a cuter name, and there's some arguments that are hidden within the API. So it will call this. And what this essentially does is, of course, it will check for null, and then it does this loop. So if you didn't know this API exists, you'd actually be the one writing this code, unfortunately. So you might be trying to replicate this for no reason. So of course, it will. We have a for loop here, which means it's going to loop through all the elements. Check if I think this probably checks whether we've reached the end or something. And then if 0 is null, if the object is null, of course, because it can process nulls, there'll be a different algorithm for that. If they are not null, there'll be a different algorithm, and this algorithm checks whether the values are equal at the particular index, and then it return that index. So this is the index that we are being given. So if it goes through all of these and none of these return functions are called, we get to this point where we return -1. So internally, this is essentially what's happening. And if you are a big fan of algorithms and data structures, it's fun to go into these collections and look at, for example, these implementations. It might also be a chance for you to see whether you could write it better. So yeah. So that is last index of. Any questions on last index of, or any pointers? Something I might have missed that's very important? Anyone? Awesome. Okay, so I guess that means we are in the same page. Remember that API so that you don't have to try and reinvent the wheel when you don't need to. Okay, so that takes us to the next phase. So we've looked at a bunch of functions by now, and we'll continue looking through additional functions until we've covered a significant chunk. So the next core operation, before we move to bulk operations, the next core operation that I want us to look at is a function called, I'll just type it here, though we'll look at it in a different file, ensure capacity. And this is a callback to the discussion we had that was very nice at the beginning about the difference between ArrayList size and ArrayList capacity. So let's check it out. So I'll just again make another file so that if you guys want to review this code later, you can. I always share the GitHub account after the session, so stick around for that. But if you're not able to stick around, it's github.com/Samuel Awino, and Kenya Jag. Yeah, you'll find it there. But I'll share the link. So this is V3, the third session, and this is the second thing we have here, I think. Yeah, .java. Awesome. So I'll make the customary main function there. And now let's look at ensure capacity. And just like the name, it allows us to confirm capacity. I like the way the naming is here because you don't have to, the name already gives you a hint of what's happening. So one thing we learned about ArrayList is the size is not equal to capacity. So if you guys remember from the previous session, we can have, let's say, an ArrayList here, and let's say this array list has country names, or let me just say countries. So it's a list of countries, and this list of countries is, so we've just initialized it. In fact, I'll just call it empty list. So this is an empty list. Deliberately, we know it's an empty list. So when we check for the size of this list, if we do size is equals to, and we check for the size, remember from collection interface, you can call all the functions from collection interface, and this particular function allows us to check for size. So from the audience, what do you think will be the value there when we run this? What will be the size? Anyone? Maybe I should also check the chat. Maybe you can type it there if you're not able to speak. 921. Okay, so I think this was related to the other thing that we are covering. So Paul, you are right. It's actually -1. Very nice. So Alex is saying 0. Anyone who thinks it will be different? I think it will be 0. Because we haven't added anything, we have not called add on this, we expect this to be 0. So if we run this, we'll see that, actually it's 0. If we add an element, of course, it will be the value of the count of the elements we add. But we learned that it does not equal the capacity of this array list. And we learned that within the array list, there's this aspect of default capacity. I'll not tread through the code. Let me just try and describe it here, because we already covered it. So an array list has size and capacity. The size is the number of elements, of actual elements, the things that you actually add into it. The capacity is the amount, and I'll be using this term loosely. If you write low-level code, and you know that this term should not be used the way I'm using, pardon me, I'm just using it as a way to explain this. So the capacity is the amount of storage available. Somebody might say memory, but it's the amount of storage available within this array list. So you can imagine it like a box. If you look at an empty box, you can already estimate the number of items you can put into that box, and they'll fit before you even add the items. If it's a small box, you know, it won't be able to fit this number of balls or this number of other smaller boxes. But the size is the actual balls, is the actual pens, the actual whichever item you're putting into that box. So size is the number of actual values in the box. Capacity is how much can you put into the box before we need to stretch it. So we also learned that by default, array lists come with a capacity of 10 elements. By default, when you add elements beyond, so when adding beyond initial capacity, when you add elements beyond initial capacity, the array list needs to grow so that it can accommodate the additional elements you are adding. And last time I saw somebody within the JDK talk about this, they talked about a 50% growth rate. 50% growth rate. So it will look at the existing capacity and get 50% of that and use that to expand your list so that you can accommodate more elements. So for instance, so we can initialize this without passing any value in the constructor here, and this will give us a capacity of 10. But you can decide to initialize it with a capacity of 50, 500, 5,000, whichever value you want. And now your array list will not grow until you reach that 5,000 value. Once you hit the 5,000 value, then it will grow by 50% of that capacity. So that we covered exhaustively, and we also learned that that will not show up in the size. So size only counts the elements. So although I've said, oh, we have 5,000, this thing can have 5,000 elements, the size will not be 5,000 elements. This is the capacity, the amount of elements that can be contained. So what does the ensure capacity do? So let's just see it in action. So ensure capacity. So one thing you need to know is that you can call it on an array list, or a list, and you call it with ensure capacity. Ensure capacity. Okay, I think I'm calling it incorrectly. List.ensure capacity. Seems to be a static function. Let me just, I've forgotten how to invoke it. So yeah, this is what we want. So it's on ArrayList, it's an instance function. Okay, so since this is a list, we are calling functions from the list. Let me just see, because it's not a common API to use. That's why it might be, yeah. So for you to invoke it, it has to be an actual array list. Okay, so let me just explain what just happened there. So remember from our recap of interfaces, if you have an interface, vehicle, let's say vehicle. So this vehicle can be it can be a bus, it can be a truck, it can be a sedan, it can be, there are multiple classes of vehicles. So that is the interface. Your concrete implementation of that interface, so the concrete classes associated with that interface can be a class bus, class bus. You could have a class, perhaps, what is another vehicle? Sedan. I think that's sedan. How do you, yeah. A more common one, so you have a bus, you can have a truck. A truck is still a vehicle. So this is the interface, this is the class. So the interface can have abstract functions that you're able to implement. The class will implement those abstract functions, but it can add its own functions that are specific to that class, to that class. So, for instance, with the bus, you might have a different function for maybe stopovers, for the bus to calculate where is the next bus stop. For a truck, you might have a function for capacity, how much load can be put into the truck. So you can have specialized functions on top of the functions that you inherited from the interface. So that is the problem we are facing here. When now you are instantiating an instance of any of these classes, you can instantiate them by just invoking the class itself and saying bus, my bus is equals to new bus. So this is a valid initialization of bus. But also you can create an instance of bus by referring to vehicle. You can say I'm creating a vehicle, and this vehicle is my vehicle, is equals to new bus. So I'll have a vehicle, but the concrete implementation that I'll be relying on is bus. So if I instantiate this, the first method and the second method, there is an important difference. So when I call my bus here, when I call my bus, I can access all the abstract functions from vehicle that have been implemented. Sorry, yeah, I can access all the abstract functions that are declared in vehicle that have been implemented in bus. On top of that, I can call any specialized functions that are inside bus. So if the vehicle had a concrete implementation like drive, an abstract function like drive, I can call that. But if the bus, like I said, can have special functions, if it had a special function like check next stop or next bus stop, which is very specific to bus itself, I can invoke that. So what I'm driving at is bus can have its own special implementations on top of the abstract functions it has implemented from the interface. If I try to use this here, with my vehicle, I'm not able to call check next bus stop. And I think that's what we were facing. Because if we go back to ArrayList, you can see that as opposed to some of the functions that we were using, some of them from the collection interface, like is empty, for instance. No, maybe is empty is not be here. Let's look at a function like get. Get that gives us a value. Actually list. So within this list interface, if you look at a function, they are all scattered all over. But let me just describe it from here. So what we are facing is this ensure capacity is a function that's specific to ArrayLists. You cannot use it with a list interface, because since list is an interface, it can have multiple concrete implementations. And if you initialize like this, what we end up with is a list. It's only that we are relying on the ArrayList to have the implementation of the abstract classes declared in list. So with that, we are not able to call empty list.ensure capacity, because ensure capacity is specific to ArrayLists. It's limited to ArrayLists. It doesn't exist in the contract for lists. So for us to be able to access it, we would have to do this my bus scenario, where we say ArrayList, empty list is equals to new ArrayList. Because ArrayList implements, let me just go to its declaration. Because ArrayList implements the list interface, all the functions that are declared abstract in list will be accessible to us when we do this. All of them will be available. But if we do this, we'll have all the functions that have been declared in the list interface, but not all the functions that are declared in the array list. Functions that are specialized in the array list will not be available to us. That's why when I switch over these, I get this interesting behavior. I hope my explanation is clear to whatever led to that conclusion. Joe, do you want to add on that, on the interface and the abstract implementation? Basically, why we are not able to do this, because it's very important to understand why.
Nothing much to add. Sorry. Exactly. Repeat the question. Sorry. Oh, okay. Oh, yeah. It's all about inheritance. Yeah. So I think list has limited methods. I don't know whether it's collection that has these added methods that we inherit. I might be wrong, but yeah, I think it ArrayList actually inherits two interfaces a bit. But if you what do you call this, polymorphism? So if you extend, if you write, if the variable type is a list, some methods disappear. But if you use ArrayList, you get more methods because they are defined in that class. Yeah.
Awesome. Thank you for that. So do we understand why we were not able to do that? First, does anybody not understand why we ran into this? Or the explanation why it's not possible to call that function the way we were calling the other function? Yes, Joe?
Another thing I wanted to add. Actually, what you just stated here is actually very, very important about having an initial size of the array list. If you are dealing with where memory is abrupt, where a lot of data is being generated and you have to insert in the list, it's better to have an initial capacity, so that the process of having the initial array and then extending it to a larger array through instantiating the backing array has to be copied to the new array and then replaced. So it has a performance cost. Yeah.
Awesome. Yeah, thank you for that addition. So the whole reason why we have this discussion of initial capacity, it's a performance oriented discussion. So first of all, so we'll understand how it works, but at the back of your mind, whenever you find yourself having to now start manipulating this initial capacity, it's always in a situation where you're trying to optimize the performance and the speed of your algorithms, especially when you're working with ArrayList. But if this is not clear to anyone, feel free. But like I explained, it's a matter of inheritance. So we can declare this, and we will not be losing anything by doing this, because ArrayList implements, because our ArrayList implements the list interface. Remember, list is an interface here. All the functionality that is in list interface is available in ArrayList. But like all relationships, not all functions in ArrayList are available in the list interface. So there's a direction to the inheritance. ArrayList will inherit everything from list, but list will not inherit everything from ArrayList. So, and one of the things that list doesn't inherit from ArrayList is this ensure capacity function. So if whenever we want to do that, we'll have to change out the way we initialize our variables. Now, this is a good point to experiment with this var keyword that I've been using, because with the var keyword, we're able to shorten the left-hand side. So it's good to know now that when we shorten the left-hand side, it doesn't initialize by interface, it will initialize by concrete implementation. So this var is not a list, it's an array list. Otherwise, ensure capacity will not be available to us. So that's important. So let's check out the documentation for this ensure capacity. And the doc says this increases the capacity of this instance if necessary to ensure that it can hold at least the number of elements specified by the minimum capacity argument. There are two places where we can do this. So one, we can specify initial capacity at the start, but also if you want to specify initial capacity at a different place, you can call ensure capacity. And now I'm getting, okay, so ensure capacity doesn't return anything. So it's a function that returns void. So I shouldn't have it here because this is expecting to string. So it's a silent function. You call it and then it will work in the background, ensuring that your array list is of that size. Why does this become important? It becomes important if you want to ensure that, for instance, let's say at the bottom here, after calling ensure capacity, I want to add the 5,000 elements. So instead of me trying to add the 5,000 elements and then we have multiple calls to grow the function. So internally you add the first 100, Java internally has to grow the array list multiple times to fit the 100. Again, I add another 300, Java internally again executes the grow function to expand it again to fit the 500. So instead of going through all of that and eating up memory and the server-side hardware resources that we are using. Imagine you have a server that's doing this. You can define the size, ensure capacity. This will ensure that after this line, the array list has that capacity to store those 5,000 elements. And now when you call add, you will not lose CPU time in the grow operation, the function that constantly expands your array list by 50% as you add elements. So this is a performance optimization function. And just like we saw in the docs and the function name, what it does It just ensures that your array list has the capacity to store your specified number of elements instead of the initial 10. And it saves you CPU time and hardware resources, and also it makes your program faster, of course, because you don't have to keep expanding the array list. Does anybody have a question on ensure capacity? So I guess that means it's yeah.
Sorry.
Yes.
So question on the initial capacity. What would happen if tuseme nimeka initial capacity ya 5000?
Yes.
Alafu niweke vitu kama 5001. Nini inaweza happen? Ama more than the initial capacity.
So what I believe will happen if you put more than the initial capacity is the grow function will be called, and if it is 5,000, your array list will now grow by an additional 2,500, which will make its capacity 7,500. So the array list, I think, will continue growing.
So I thought that it's a fixed size. When I go beyond, it complain. I don't know.
That's actually good because it's something we can experiment on. So let's do an experiment on it. So 5. So we've called ensure capacity, which means moving forward, our array list can host 5 elements. So let me add. So it's no longer an empty list. Let me name it correctly. Let's call it big list to match the occasion. So big list, and this big list we call ensure capacity, which sets it to 5. And if we call big list dot add, and we add so let's add the first element. What's the type? We've not even specified the type. Okay, I see why people don't like that var keyword. Because we might even get away with not specifying the type here. So let me add the first element, second, third, fourth. Yeah?
You could have specified the type on the right hand side.
Or here, yeah, but yeah, so yeah, you're totally right. So I can also specify it here. So I guess the only thing that I'm not getting is the ID warning that it doesn't know the type. Which is so interesting. Anyway, just curiously. Oh, okay. Just seeing something here. Okay, this is IntelliJ needs to probably provide some guide there. Okay, so anyway, I add 1, 2, 3. So this is 2, this is 3. Let me work with a small value so that I repeat myself less. So the capacity is 3. I've added 1, 2, 3 elements. So let me first make sure that this works. So big list dot size. Let's see the size, but also let's see the elements. Big list. And let's just try and print it here. And if we run it, we see our big list has 1, 2, 3. Its size is 3. But of course, we know the capacity is 3. So now after that, let's try and add another element. So we add a 4th element, and we add a 5th element. And first of all, we don't know if this operation will succeed, but let me just do a printout after adding. Okay, my copy failed. Let me try again. So this is after add. Print line. So after second add. So okay, let's see. So we had 1, 2, 3. Size is 3. So after the second add, we have 1, 2, 3, 4, 5, and now size is 5. So we've called ensure capacity, but the ArrayList internally still allows growing beyond that initial capacity. So if you specify it and then you break the contract, the ArrayList takes the liberty of keeping your program running. What do you think about that, Kennedy?
I never knew. I thought that when Nikki specify, I never knew it resizes. If it does, well and good. It's a good thing, maybe, unless Joe has something on that.
Not much. Well, actually, I think the code he showed on the ensure capacity, the grow method, the percentage, even the 5,000 you were saying, then you add 1. It will ensure it increases quite considerably, so that if you add another 1 at 5,002, there's no growing again. So it's more like a safety net. I think they did an analysis on how arrays tend to grow, so they took the optimal way of ensuring the capacity grows with a percentage of, I think, the array size, if I'm not wrong. Yeah. You can make a high performance array list. You call it int list. It would be very high performant, very high performant. There was a time I made one because of that. Yeah. This arrays dot copy is very fast. Yeah. Very fast.
Okay, yeah, thank you for that input. So at least now we know when you ensure capacity, yes, the array list will expand to fit that capacity that you've specified. But if you break the contract and expand your array list even further, internally Java will not break the program. Instead, it will break the contract that you created with the ensure capacity, and it will continue expanding your array list. Because of course, if it doesn't do that, then you get to index out of bounds, where you're trying to add elements to indexes that are not in the array list. But at least now we know the behavior that will be there is the array list will continue growing. But the advantage of ensure capacity is before you hit that capacity that you specified, you'll save yourself a lot of CPU time. Your program will be much faster because of one thing. You will not need to call this function repeatedly, this grow, which of course Java will calls internally if you are stretching beyond the capacity of the array list. But if you specify the capacity and you stick to the capacity you specified, then it will not grow. So you'll be saving yourself time on this. So it's just like Joe was mentioning, this array.copyof is a very fast algorithm. And if you specialize the type, like he was talking about having an int array list, the more specialized your array list becomes, the more you can do performance optimizations on it. And there'll be two gentlemen teaching performance optimization of algorithms in the future classes of this series, namely Ian and Cosmas from part of our organizing team. And they'll dive into these performance optimization opportunities even more, so that when you start using ArrayList, you write very fast and efficient programs. So this is what the algorithm does. If you want to explore it, take time and check it out. But essentially, this is the algorithm. Yes? Just go ahead. Whoever is speaking. Okay. But again, feel free to interrupt if you have any question or comment. This is what it does. So I was just trying to peruse here and trying to see that I can detect that 100%. But the algorithm is a bit more complex because I'm seeing some unary operation there that we won't be discussing yet. No, not here, bitwise. I think that's called bitwise operation, something like that. Okay, so we've looked at ensure capacity, which is nice, and our time is ending. But I would be very happy. I'm very happy to announce that we've finished core operations. So now we'll get a chance to move into bulk operations. So what we should be able to cover in bulk operations. So let me just make a file here. Session. So this is v3, and we are now at 3.java. So now the next step is bulk operations. So bulk operations are where you are moving multiple chunks of data across. I can happily announce that in future we'll be doing stream processing, and we'll learn, I think it's called data-oriented programming. We'll learn a bit of that, and it is some very interesting stuff. But here we'll be getting a taste of it. So one bulk operation you could be doing is searching. Sorting can also be considered a bulk operation. Replacing. So when you replace multiple values, so you go into an array list and you shuffle around like 10 of the items there, and you replace them with different values. And a bulk removal also, bulk removal, and also there is bulk addition. So allow me to cover just a bit of this before we close tonight's session. So with addition, let me just make a simple list here, and this list is a list of integers. Just make sure I don't overstretch. So we have a list here that can store. Let me use string this time. So we have a list that can store strings, and of course it's an array list. And we learned that you can call add to add items to the array list. So let's say this is an item of fruits, a list of fruits, and what we can do is we can add some fruits to it using add. So we can add an apple, and we may add 3 more. So we get an apple, we get a banana, we get a mango. Okay. So that's our fruits list. We can have another list here, and this list is of that can store various types of meat. So white meat, red meat, various types of it. So we'll add some meat here. Let's add some white meat with pork. Let's add, I think chicken is white meat. And yeah, I think those are the 2 that I'm sure. So red meat, let's have beef. So now, if we want to create a separate list, the third list, and this is a list of a grocery list. So it's a grocery list that you're going to the supermarket to buy items with it. And this grocery list will be composed of fruits and the meat that you're going to buy. So instead of adding, so you can go ahead and call grocery list and call add multiple times and add all of the items, because you'll end up buying the fruit and the meat as well. What you can do is you can invoke the first bulk operation. I think we've explored this one previously, which is add all. And with add all, it allows you to add a collection. So you pass in a collection. So, and remember, list is a collection. So that means we can pass this list into that array list. We can also add the other one. Instead of adding each individual item, we can call add all, and we add the meat. And now if we print out our grocery list, we'll see what it contains. Let's run it. So we see it contains apple, which is from fruits, contains banana, mangoes, pork, chicken. It contains beef, which is from the meat list. So you can add, you can take a whole collection and add it into another collection. So that is the first bulk operation. Another thing you can do is, so let's say you're on your way there and somebody called and they said, we don't need the meat, we already have enough meat in the fridge or whatever. You can remove all the meat. So you can call grocery list remove all, and with remove all I can say remove all the meat. So, and we can see after remove all, so after removing meat, let's see what the grocery list will contain. So if we run it, after calling remove all, we'll see after removing meat we are left with apple, banana and mango. So the same way, if we end up removing all the fruits, dot remove all, and we pass in the fruits array list, or list in this case, we can see after removing fruits we end up with the new grocery list. And the new grocery list, as you can guess, is now empty because we removed all the fruits and we removed all the meat. So that is the bulk removal. So you can remove all items. So let's say we are still left with the meat. So we've looked at adding multiple items. We've looked at removing multiple items. What if we wanted to replace? So with the replace, you can call grocery list dot replace all, and just like the other one, we can pass a list. So let's say we don't want to remove all the fruits, but there are some fruits that we already have. So let's say this list is exempted fruits, because we know we are only left with fruits at this time. But we don't want to remove all the fruits, but there's particular fruits that we already have. So we, in this case, let's assume we already have apples. So I'll remove apple, and we already have banana, or we are not in the appetite for banana, so we decide to remove it. So instead of removing one by one, we can say grocery list dot remove exempted fruits. So I'm seeing a problem here. Okay. Unfortunately, this leads us into another area that we might not be able to cover. So unlike add all and remove all, with replace all, we can't just pass the list. Instead, we have to pass a condition. We have to tell it check for this condition, and we could cover this, but this is related to something we are supposed to cover later, which is Java 8. And when anybody says Java 8, the thing that comes to mind is functional programming. So we've currently only covered OOP, which is object-oriented programming. So we won't be able to cover this now, but I came up with an adjustment to the curriculum a bit, so that we'll be able to cover it before we get to functional programming, because there are some things in between. So we'll be able to cover it sooner than waiting for that. But in this session, we won't be able to cover it. Just know that there is that capability, but the argument we are passing in is a bit funky. It's a bit different, but we will cover it. But it's not too different. It's just an interface, but the guy it extends this other guy called function. That's where things get a bit complicated. So we won't be covering it now, because there is no simple way of explaining it without teaching some functional programming concepts and some features of Java 8. So with the bulk operations, I think we can look at we can already learn how to use add all, remove all, and we'll look at exempting later. But if you wanted to achieve this operation without using bulk operations, I believe you can still do grocery list dot remove, which we covered earlier, And with remove, you remember you can pass in an index or the object, and here we can say remove apple, and we can say remove banana. Although now that this is no longer a bulk operation, but the same operation can be achieved. But if we do this with bulk operations, we look at functional programming and see how that works out. So let me just print out the last case. So after removing apple and banana, what are we left with? Grocery list, we are left with mango only. So first we removed the meat, we are left with these 3 fruits, and then we removed apple and banana, and now we are left with mango. So that's how we can do those operations. There's another operation here that we are not able to do because there's something else we need to learn, which is sorting. Searching we can already cover, I believe. So with searching is where, so this is searching. So this is very common. Anytime you're working on a real life application, this is something you'll be doing. I mean, you have Google search, every application has like a search bar at the top where you can search. So this is very common, and it's something you'll be doing a lot. So with searching, you can call grocery list. So one of the search functions that we explored, or some of the, not even one, some of the search functions that we already explore is contains. Remember contains, where we were able to check whether it contains a value. There's another search function that you can use for search. You can do a search index of. So index of also checks whether there's a value. If there's no value, you guys remember it returns -1. Last index of. Last index of as well. If there's no value, it will give you -1. So also you can use it to do searching. So we've already explored these 3. Maybe the third one we can add in the picture, and I hope this doesn't depend on lambdas. Nice, it doesn't depend on lambdas. So contain, this contains all. So just like remove all, we can pass a list here and use it to check whether it contains those items. So with this, let me use a different example. Let's create a list, and this list just is a string. Of colors. So new array list of colors, and I'm just going to populate it with a few colors. So I'm going to add blue. I'm going to add another color, which is black, and with contains all, we can so this is the original list of colors, and let's say we have another list of required colors. So let's say you got a painting job, and there are colors that you're already prepared with. There's some paint you're already prepared with, but there are some colors you don't have, but you want to check whether you have all the colors that the client requested. So you can have another list of required colors. That's probably coming from the customer that you're going to do this painting work for. And the required colors, this customer wants you to paint blue, just like you have in your list. They also want you to paint perhaps pink color. So you can check whether you have the colors that the customer wants. And the way you do that is you can call the colors that you have, the list of the colors that you have, and call this contains all function. And the way this contains all function works, it will only return true. I think it's a boolean, if not an integer. Yeah, so it's boolean. So it returns true only if all the elements match. If all the elements that you're checking whether they are contained in the list are present in the list. If even one of them is not present, it will return false. But it doesn't check that they are the same size. It just checks whether all the elements are contained, and we'll explore that a bit. So here we expect to get a boolean. So I'll use explicitly boolean. Matches, contains all required. So it has all the required colors. And we can go ahead and do a printout here for that, and contains all client colors, and that will be the Boolean value. And if we run it, we should be able to see contains client colors is false. And why is it false? Because we have this pink value. So let's say we go back to the hardware store and we get pink, and after adding pink to our colors, we check again, and now if we check, we see contains all client colors returns true. So the sizes can be different. You will see this required colors has 2 items. These colors that we have, the paint colors that we have, has 3 items. So you can end up with different sizes, but what this contains all function does, it just checks that all the values in the list that you're passing, all those items are present in the list, the destination list, which is this one. So it doesn't mean that they are the same list, and that they have the same element and all the elements are equal. It means this list is a subset. I think that's a good way to explain it. It's a subset of this other list. If you've done some discrete mathematics, or I think anywhere in statistics, you might be familiar with set operations. And although we are not using sets yet, but what we're doing here is somewhat similar to set operations. So with set operations, we usually have union. The other one, is it called disjoint? The opposite of union. What is the alternative? Anyone from statistics? Set operations, essentially. You have union. What is the other one? So union is if you have A, B here, and you have another list A, B, C. I believe the union of these two will be A and B. So it looks for the values that are present here and the values that are present here. So they form the union. There's a name for the opposite, which is looking for the values that are not present here, which will give you C. But anyway, that's I'm going beyond the scope of this. But essentially what we are doing here is sort of a union operation. So this and this don't have the same number of elements, but we can check whether this other list has these elements. It has to match all the elements in this, but this doesn't match. I need to match all the elements in the other one. So, yeah. Any questions? Okay. So, I've tried to stretch this a bit beyond our stipulated time. So I'll just publish the code so that you guys can go through it. And if you need to like recap this, if I'm preaching to the choir also, no pressure. We'll continue advancing this adventure of exploring ArrayLists. So this is ArrayList class number 3, and we'll continue exploring this. Yeah. So the next thing we'll be looking at next time is sorting and bulk operation. And the reason why I've set it aside is when we look at it, we'll be looking at, and I will be brushing up on our knowledge of interfaces again. We'll be looking at an interface called the comparator interface. And this will be fun. We'll look into implementing what you need to do to implement your comparator interface, and also we'll check whether there is any implementation within the Java collections framework that we can already utilize. So that will be the next thing. Otherwise, this concludes the bulk operations. Just to give you guys a roadmap, after bulk operations, we'll be looking at this. Of course, we'll look at the comparator interface. I'm hoping that we'll also be able to look at the functional interface so that we can use it to dig deeper into some of the APIs within the Java Collections framework. And then there's something we haven't done which is very important, which is iteration. So we'll also look at iteration. There's specialized iterators. We created our own freezer iterator here, if you guys remember. So it will be something similar to what we did, but we'll also be exploring some enhancements to those capabilities. And that will be, after we do iterators, that will conclude ArrayList, and we'll be able to move to the next collection interface, which will be sets. And then we do maps, and and that will be fun. Any questions? I've reached the end. Thanks, Lois. Yes, John?
I don't know whether you'll touch on or you touched on it on variants of yes, or array lists, for lists or collections in Java. Oh, okay. It's some rules. Actually, they're the most confusing rules. I always forget once in a while. So if you have a shape, an interface shape, and then you extend you create a circle extending the shape. So if I create a list which is shape, can I add? If I create a circle list and then assign it to another reference that was created using list shape, can I add, and then maybe later on I don't know whether you're supposed to add or get. There will be some serious exceptions. There will be serious issues when you are trying to add any object inside it. Yes. So there's a covariance and controvariance.
Okay.
And that's where generics comes in. Yeah.
Let me see if I can get it. So number, I don't know if you can do it with number. Although number is not an interface, it's already.
But I don't know which other integer extends number. Yeah.
Yes. So if we had integer, let me make it explicit. If we had integer here, let me call it value is equals to 32, and we added that to number. We added that to numbers.
Yeah.
So okay, explain how. Guide me through how I can use this to explain it.
The idea is that let me try to remember where I wrote it. Yes. So so you created a list, and then what let me check what you've written. Yes, this is okay. And then enter after array list. And then write another one, list.
Or another list.
Integer. And then is equals to numbers.
Is equals to okay, like that.
Yes.
Okay.
In some languages this is allowed. In Java this is not allowed.
Okay. So so essentially, but also this is an interface. Would it work differently if this was an array list?
Yeah. It's fine actually.
Okay, but it's still checking the same thing.
Yeah.
So though they are the same type, I cannot instantiate I cannot instantiate a list of numbers with a list of integers, although integer inherits from number.
Oh, actually it's vice versa. Sorry. Yeah. Actually, yeah. It's fine. No, it's vice versa.
Okay.
Put the array list as integer. Sorry.
This array list.
Yeah, integer. And then lists it's a number.
Okay.
So because number is a super type of integer, if I add, it should be the same actually, because if you write number x is equals to maybe a value integer, it will accept when you create a separate variable like number n is equals to new integer 5, that it will accept. But if you put that in collections, it should be, because remove the array list, just write list up there. Yeah, so it's supposed to be super type of number, so theoretically it's supposed to be assignable. Yeah, so, yeah, in some programming languages, I think Kotlin, Scala, this is acceptable.
It's the same problem we were running into when we were doing generics, where we would expect that Java would understand the relationship between our classes, but then it would not understand the relationship, and then we would end up in some awkward situations. If any of you were in that generics class, we were facing sort of the same problem, because here number is a super type of integer. So if I try to initialize these numbers with integer, it should be okay, because integer inherits number, so it will have the same characteristics. But because of how the language is structured, it doesn't allow that to happen.
Yeah. Now, I think for it to work, I don't know whether it will work. Just put a question mark and then extends.
Oh, here?
In the list number, yeah.
Oh, okay. Oh, this one, eh?
Yeah.
Okay.
Question mark.
Extends number. Oh, yeah. Then it would work.
Yeah, it will work. But now, press enter. So write ints dot put.
Oh, I think it's add, or
add. Sorry. Yeah, add.
okay.
And then new integer, or just put a number. I think it will box automatically if I'm not wrong.
Okay.
Yeah.
Like that.
No, just write new integer.
It won't know. Okay.
Yeah.
Because we're using number here, so the inheritance tree is a bit strict. Although it's still refusing.
Yeah. This is fine actually. Sorry. Just return the 32. Just the 32 alone. Actually, no, I understand. Yeah, 32. So you cannot add.
Okay.
But in the numbers, add numbers that add 32 will work.
Yeah, because here it knows it's an integer.
Yeah.
If I add that, it will fail.
Yes. So here, this is called covariance. So you can only add, and this is the reason why you cannot add the super type. And this equates to something interesting that you are aware about, but you have never really connected the dots. It's same as immutable arrays.
Oh.
Yeah, this is just immutable arrays actually.
Okay. Because the type is locked into how we initialize the array list.
Yeah, it can only produce, not add. Yeah, you cannot produce or this is the approach they want to take once they introduce. Most languages came up with immutable arrays. I think C# in the beginning, so they knew the rules early on. I think it was a mistake by Java.
Okay.
So and then now the other way. So right now, so you can remove the int adds, the one, or you can put the whatever, the
like that.
what do you call it? Yeah. Now And after it, just it's something new. Yeah. So write list.
Or a new list, huh?
Yes. And then question mark. Super
Oh, yeah.
integer.
Yeah.
Just a variable name,
Int B.
and then is equals to new array lists. And then int b that add now an integer 32. It works, but now again below int b get, yeah, 0. Try to run it. I think, I don't know. Just try to run it. I think it's supposed to throw a runtime exception. Oh, yeah. How? There's a way it's supposed to refuse. I've forgotten the approach. Yes. Oh, yeah. Sorry. The default return is an object. That's why. Yeah. Yes. That dangerous casting. Yeah. Yeah. So those rules are very difficult, but some languages were able to solve it correctly using generics. But the reason why Java is not capable is because it has no specialization, meaning the wildcards or the generics are the information on what exact type is not available, aren't they? Because the generics in Java are erasures. Yeah.
Yeah, I mean, we constantly ran into this problem while covering generics, where we were expecting that our inheritance tree would be understood by generics, but we found there was a lot of restrictions in what you can do. Thank you so much for pointing this out, because this is also something that we are not able to cover. I think we're not able to cover. We're able to cover the wildcard feature, but we're not able to cover super. We only used this format where you check that whichever instance extends from number, so you'd pass in the class that you expect that the values you'll be passing extend from. But we were not able to cover super. So super is the opposite, which is saying this has to be a subclass or a class that can be implemented by. There's a way that relationship works. So
yeah. So if they had initially done the correct way when Java came out, certain methods will not be available, like get should not. No, the other one, the covariance one, the method add wouldn't have been available at this situation.
Okay.
So those are the mistakes when designing languages. People encounter, they realize later, hey, this is a huge mistake they've done.
Yeah, but it's too embedded into the language. So there's, but knowing Java, they'll probably in future they'll go for a conference, and then in that conference somebody will make a presentation, and then there'll be a follow-up 2 years later, and then in the third year or the fourth year it will be announced that they are enhancing generics, and then 1.5 years or 2 years later after that we'll get a fix for some of these limitations.
Yeah. And actually they'll try to specialize. If the type is a value class, the information will be retained during runtime.
Yeah, I think even the value classes enhancements will address some of the shortcomings of generics, because value classes will change the type system essentially. At least enhance. It will enhance the type system of the language, which means generics will be affected either directly or indirectly.
Yeah.
Okay. So this has steered into Java by example, which is supposed to be on Friday. This is where we have these expert level discussions. But thank you for pointing that out, because this is a very a good situation that we're in, where we can first of all recap some of the things we learned in generics, and also try and also remind ourselves of some of those boundaries that we work within the language, especially when you are using inheritance hierarchies like so. So thank you so much for that, Joe. Is there something else you want to add, Joe?
Did you touch on iterators yet?
Yeah, so iterators is supposed to be so from now that will be the third thing that we cover. So we'll do comparator interface so that we can cover sorting, and then we'll do functional interface, and then we'll do iterators. Although we can do iterators before functional interface, but I'd rather we do it before, so that we can also talk about the enhanced for loop, the Java 8 enhanced for loop. Because if we talk about the enhanced for loop and we don't know how ArrayLists cover iterators, then they have a bit of a relationship. So we still have it in the lineup.
I'm actually even happy you have mentioned two things there. One is the iterators, and then comparators. Yeah, so iterators were a design mistake actually in Java. They also realized it late. The reason is certain classes also require iterators, but when you have already developed that class, incorporating that iterator later on in a library that has already been compiled and provided by a third-party person, it's difficult to add the iterators there, because you have to extend or implement the iterator. So you don't get the enhanced code for loop. And then comparator, there are two classes. I think one that is inside the list, where you compare, comparator, and then there's its own class called the comparator, which is a static method. Yeah, so in future, that's a limitation by the language itself, because imagine you have created a type like a record, and you want to add behavior or a method to it. It's like extension methods in Kotlin, sort of.
Yeah, even in like a language like Swift, you get extensions where in some way you feel like you're enhancing the language itself by adding your own custom functionality.
Yeah, but the extensions are different. Extensions, you take a method derived in another class, but what Java is aiming for is that you'll develop your own methods independent of that type. Yeah.
Okay. Yeah, that's different. And that's very different.
Yeah. So like iterator should have been its own class with its own behavior, and you can register which types it can accept. So yeah, so you create that instance. It's a static final instance, and then the compiler will detect that this method is attached to this type. So yeah, so by that the compiler can now detect maybe for loops, those enhanced for loops, etc. But it's a discussion, I think, after value classes. That's the area they want to concentrate after, because it will introduce operator overloading. Yeah, and many other enhances like collection, literals, like the way you are saying add. That's too complex. So in future you can initialize the array lists in one line. Yeah.
Yeah, so that's one of the features that I like when writing my other favorite language, which is Swift, in that you can declare and initialize in line. Although with ArrayList you can also do that, but you can do that by passing another array list. So if you have this list colors and required colors, I believe you can initialize by passing colors here in this constructor. So this will do an equivalent of add all. It will do like an add all operation here.
Yeah, but now that's a method. So imagine the way you initialize int arrays, like primitive arrays, usually use curly brackets, like just write int, native int, yeah, and then is maybe and then is equals no, just curly brackets. Those, what are they called? Yeah, no, yeah, yes, and then add three, and then at the end of add uh, five, then add a semicolon at the end to remove the error. Yeah, yeah. So imagine in future you develop your own lists, like the library I made, and then I initialize my list, my custom list, this way, the way you have done array. Yeah, so it's an interesting, and once you teach people, I think tomorrow later on, about comparator and iterator, it will be easy actually to understand the concept later on when it's going to be introduced here. Yeah, so what some actually you're teaching will be a gateway to a very interesting direction Java is going to take. Yeah.
So that's why I'm so excited in covering the collection, because the collection interface is a cornerstone of the language. It's a key part of what makes Java powerful. And for those who are probably, if this is like your first time looking at the language, I think where we've gotten, you can already see applications where now you can actually apply this in your code. You can see how you can move data around, how you can do operations on data. So collections is essentially the gateway into the language. And in that, I would probably recommend, again, if you guys get time, there's this documentary. Let me try and get it by Google search that you guys don't see my recommendation feed. There's this C++ origin story or something like that. So there's this story of C++. I would highly recommend that you guys take time and watch it. Of course, YouTube and their ads. It's here, and within this documentary they talk about when there's a Russian software engineer that introduced the standard. I think I'm not very familiar with C++, but an equivalent of the standard library, or an equivalent of the Java collections framework. He worked on introducing it into C++. And when he came up with the structure and how it would be added to the language, the standards committee that was in charge of, that is essentially still in charge of what goes into C++ and what doesn't, they essentially changed their rules so that they would adopt the thing that the guy had developed. I'd recommend you guys take time and watch it. The equivalent of what that introduced into C++ is similar to the Java collections framework. This is a very, very important part of the language. Apart from the type system, I don't think there is anything more important in Java than the Java collections framework. So this is very, very important. And I hope we are like learning together, and you guys can apply this. Check out the documentary. You'll be able to learn a lot, even if you don't write C++. Just seeing how languages evolve, how they're designed, what is important in the language, what isn't, and some of the shortcomings. That documentary did a really good job of exposing that. So you guys should really check it out. So Joe, is there anything you want to add?
Maybe to say collections or lists are so important that they single-handedly made Python famous. Yeah, even if it's a slow language. Yeah. So. Yeah.
You'll find it, and you'll find all the code that we worked on today, and the collections class. So this folder, and just like I arranged them, also the commits kind of reveal where they are. So all the source code will be available there. So let me just share that link, and yeah, it should be available to you guys. Otherwise, if you are new here, we do this every Thursday and Tuesday and Thursday, and we also have Java by example resuming this Friday. So I hope you guys join us for that tomorrow, same time. I changed it to no, I didn't change it. It will begin at 8. That one is usually 2 hours, so 8 up to 8 to 9, 9 to 10, so 2 hours from 8. And there we do what Joe was just doing. We do expert level discussions, and we really dive into the weeds of the language and some of the frameworks in the Java ecosystem. Otherwise, if anybody has any question or comment, you can do so. If not, I think, okay, does anybody have any question or comment? So Joe had promised a hint on the library. Yes, thank you so much for asking about this, Steve. So we'll be having a very detailed session on foreign function and memory API. That is a fairly new addition to the Java language. Foreign function. In fact, I think the abbreviation FFM. If you just look for FFM Java, foreign function and memory API. So Joe is going to take us into a deep dive into how to use this. I've just shared a documentary on C++. If there's anything on C++ that you like, but you don't want to write C++ yourself because Java is awesome, you can write your own Java and then you call C++ or C code directly from Java. Initially, the way you do that, there's something called JNI, Java Native Interface, but they improved it by introducing this other new library. It's not just a new library. No, Joe will be able to emphasize on that. It's called Foreign Function and Memory API, and what that allows you is allows you to call native code. Very important if you are doing AI research, LLMs, AI. You hear people talking about AI. If you go at the foundational level, the main AI project is TensorFlow, which is written in C++. And if you want to have your own system that actually leverages TensorFlow to train AIs, but with Java, you can do that using this foreign function and memory API. And Joe will be taking us through it. So the time for that will be on, let me just get my calendar. So the time for that will be, I have some emails here, but they are not sensitive. So the time for that will be on 19th. So in your calendar, mark 19th, 8 p.m. to 10 p.m. That will be on Friday. That is next week, Friday. That is when Joe will be taking us through FFM and the library that he's working on that's related to FFM. Is there something you would like to mention on that, Joe? Apart from booking the date.
I'll actually concentrate more on memory. Functions, I think they're a bit straightforward, but memory is the most difficult thing actually. Actually, we enjoy a lot with Java because we don't think about memory. But there's a lot that happens behind the scenes. So I'll try to explain exactly what it is. And then the class file API, I'll just go through briefly. There's a new class file API. Yeah, it's called class. Yeah, class file API. It can generate bytecode during runtime. Yeah. Mm. No. It's so separate from this. Yeah. Actually, to me, it's the most beautiful design library in Java, to be honest. Yeah. Actually, when Brian presented it, I think in Java 1, I don't know which year, the presentation trended a lot. Because they did a very complex thing to and simplified the API. It's once you understand it, it's a very nice, convenient API. And very fast.
So, like I was saying, I'm personally looking forward to that, and opposed to just working with JNI through basic examples. This will probably be the first time, personally, for me to see how you bridge the two worlds, which is hardware level languages like C and C++, and our Java ecosystem, and so it will be very nice.
Actually, what you're presenting here is almost the same thing you are presenting today.
I'm seeing there's some similarity. Also, I'm seeing some C here, which is nice to see. Let me not get into it. I might spoil it for you. Guys, mark it on your calendar, 19th. That's when we will meet for that. Awesome. 19th, which will be Friday, 8 p.m. to 10 p.m. Don't miss out. Thanks, Lois. I'm glad the session was great, and I also maybe another thing. The session is backed up on YouTube. I'll share the link to the YouTube recording after this. But nowadays I usually do live streams so that I don't have to like download, record, edit after this. So it will be available to you to recap if there's anything that you didn't understand, and also the source code is there for you to peruse. If you have any questions, anytime you can reach out in our WhatsApp group. If you're not in the WhatsApp group, just let us know and we'll help you get in. Otherwise, I think this has been super awesome. There's even more fun things we are going to cover next, so don't miss out. So with that, I think I'd wish you guys a wonderful night and happy weekend. For those who are joining us tomorrow, no need for happy weekend. I'll see you guys tomorrow. So have a good one, and I hope you guys learned something. So see you on the next one, and thank you so much for coming and making this session fun. Okay. Bye bye. Have a good night, guys.